So today we are starting our third lesson in chapter 5, and so far we've done solving systems by graphing, solving systems using substitution, and solving systems using elimination. Now, if you have not completed the solving systems using substitution yet, again, that's due on Wednesday. Do not confuse that with this lesson. Okay, because we're doing the same thing as far as we're trying to find a solution to a system. We're trying to find an ordered pair, but we're going to use a different method today. Okay. And so when you're completing the homework with substitution, make sure you're using that method. When you're completing the homework for 5.3 using elimination, make sure you use that method. All right, so the process of using elimination is in the word elimination. You're going to eliminate a variable and solve for the other one. Okay, but the very first step that you need to do is you need to put your equation in standard form. So standard form, does anyone remember what standard form is? No? Okay, it's AX plus BY equals C. So basically your X plus your Y equals some number, okay? So what that means is that you need to get your X and your Y on one side of the equation. Let's look at this first one. Convert both of your equations into standard form. You do not have to change the coefficient in front of the X to positive. So the correct way to write standard form means that the coefficient in front of X has to be positive, but in this case, it doesn't when you're solving systems, okay? So I'm going to write out this first equation right here. 2y equals negative 5x plus 9. And I'm going to rewrite it into standard form. So in order to rewrite it into standard form, both my x term and my y term must be on one side. So I'm going to move my x term over to the left side. Okay. So now I have 5x plus 2y equals 9. So this one is in standard form. I'm done converting equation 1 into standard form. Now I'm going to convert equation 2 into standard form. So let's rewrite this one down here. Okay, we need to do more than one movement here. We need to move our negative 7 over. That represents C, the term without a variable. And then we need to move negative 6y over here. So the first thing I'm going to do is move negative 7 over. We still need our x and our y on the other side, so on the left side. So I'm now going to add 6y to both sides. And I get negative 5x plus 6y equals 7. Now, when you're writing them in standard form, make sure your x is first and your y is second, okay? So step 1, put them both in standard form. Now, step 2, I'm just going to shorten this up. We're going to stack them and we're going to add them. Or you could say stack and combine. So I'm going to take my first equation, 5x plus 2y equals 9. And I'm going to put my second equation right under it, lining up my variables like this. And I'm going to solve it like an addition problem. So what's 5x minus 5x? Yeah, it's 0. So those just cancel out. Look, I've just gotten rid of my x's, so now I'm just going to solve for my y's. So 2y plus 6y is 8y, and 9 plus 7 is 16. And now, in order to find y, I'm going to divide both sides by 8, and y equals 2. So I've just found I found half of my solution. Remember, the solution to a system is an ordered pair. So you need the X and the Y. We found the Y, now we need to find the X. So we're going to take the value of the variable we solved for in step 2, and plug it into one of the equations you started with at the top. It does not matter which equation you choose. So in this case, I will take, I am going to take 2, and I'm going to plug it into the first equation for y to determine the value of x, okay? So I'm going to write out my first equation, 2y equals negative 5x plus 9. And so just in case that was a little bit confusing, all I did was I came to the top and I chose this equation. I could have chosen this one, but I chose the first one. It doesn't matter which one. So, and wrote it down here. And now I'm going to plug y equals 2 into this equation where y is so I can find x. So we have 2 times 2. So I just got this from here and plugged it in there. Equals negative 5x plus 9. And now I'm going to solve for x because that's the only variable I have left in here. Okay. So 2 times 2 is 4. I'm going to subtract 9 on both sides. And now I'm going to divide both sides by negative 5. Oops, I crossed out the wrong one. Positive 1 equals x. Let me fix that. Yeah, a lot of people think so. Okay, so then our final answer, remember x goes first in our solution, 1, 2. Now remember, if I wanted to check this, I could take my solution. One, 2, and I can plug it into both of these equations. And if it is true for both equations, then my solution is correct, okay? All right, let's go to page 2. So the first step in elimination is always to put it into standard form. And you will notice that both of these are already into standard form. So step 1 is done. Step 2 says to add or subtract the two equations to eliminate either x or y. All right, so in order to do that, we're going to stack them. So let's go ahead and stack these two equations. And so I'm going to come down here and I'm going to rewrite my equation, 2x plus 5y equals 17. And then I'm going to stack this one underneath it. And then I'm just going to combine my like terms. So 2 plus 6, or 2x plus 6x is 8x. 5y and negative 5y cancel out. And this equals 8. And now we divide by 8 on both sides. And x equals 1. So we have our first half of our ordered pair. Now what I'm going to do is I'm going to choose one of these equations to plug x into. And this one, It doesn't matter which one you want to use. I want to use the first one, but you can use the second one and still get the same answer. So I'm going to rewrite the first equation. 2x plus 5y equals 17. And I'm just going to substitute 1 into where the x is to solve for y. And you should be able to solve from here. So go ahead and finish solving this. Check your answer once you're done. Are there any questions on this? Okay, what I would like for you to do is I would like for you to try number 2 on your own. Number 3, there's an extra step we have to do. So just do number 2, and then we're going to come back and I want you to check your answer after you've had an opportunity to try it on your own. And then you could also check with your partner. Okay. So I'm going to pause the video and come back with the answer showing up on the screen. Okay, go ahead and check your answer for practice 2. So when I plug my y value in, I plugged it into the second equation. Did anyone plug it back into the first equation? And you still got 2, correct? Yeah. So that's just proving the point that it doesn't matter which one you use. All right. Is anyone still working on this, trying to correct it? Okay. I'll pause the video and then we'll come back and we'll do example 3 because I want you to pay attention to that part. Okay, so let's look at example 3. I want you to look at those numbers. Is there anything that we can cancel out on that? Okay, the 3's are the same, but they're both positive. So if we were to combine those, we would get positive 6y. Yes. Okay, but we don't want to cancel out the 5s. We want to cancel out a term with a variable. So I'm glad you said that. You never want to cancel out the C term. 3y's into a negative. Good. So, well, if we turn one of the 3y's to a negative, what would we do to that term to turn it to a negative? What would we have to do to it? Yeah. We could, but then we'd have to move the other term to the other side so that we can line them up. Yeah. We will eventually subtract. Watch what I do here. On this first one, in order to turn this 3 to a negative, I'm going to multiply it by -1. But if I multiply this term by a -1, I have to multiply my 7x and my -5 by a -1. So I'm going to multiply the whole thing by a -1. So now I get -7x minus 3y equals a +5. Now, a lot of students forget that you have to multiply every single term by that -1. Not just the one that you're trying to change, or not just the x and the y term, but you also have to multiply the -5 by a -1 also. So every single term gets multiplied by a -5. Now, these two are opposites, and we can cancel them out. So let's stack it. So we have 2x plus 3y equals 5. So -7x plus 2x gives us a -5x. Our -3y and our +3y cancel out, and then 5 plus 5 is 10. we can figure out x by dividing both sides by a -5. And x equals a -2. So go ahead and plug that into one of the other equations. It does not matter which one, and solve for y. If you are waiting, you can go ahead and look at practice 4. You don't really have to change anything on that one. Okay, any questions on practice 3? So on practice 4, do we need to change anything here? No. So because our y's are going to cancel out, one's positive, one's negative. So I'm going to stack them, but I put this on here for a reason. What's x plus x? 2x. So a lot of times students forget that there is a 1 in front of them and they just put x. But if you have 2 of them, you have to add them together. 1x plus 1x is 2x. Don't forget that, okay? And then your y's cancel out, and 9 minus 1 equals 8. Okay, so I'm going to pause the video, and I want you to go ahead and finish this one if you have not done so. And then if you do finish and you're waiting, go ahead and try practice 5. Okay, check your practice 4. All right, any questions? Hey, I heard some, oohs and ahs over this one because there are fractions. So listen, we're gonna clear the fractions. That's what we're gonna do, and then we're gonna solve it like normal. Then this has a 0, but the 0 doesn't mean anything. You're just gonna combine like terms, right? So if it's 0 plus something or 0 minus something, you just combine them. So what is the greatest common factor between 3 and 2, or the least common multiple? 6. So I'm going to multiply each of these by 6. Okay, that's all we're going to do. So 2. So this one becomes 2x. This becomes 3y. And then 6 times 1 becomes 6. Okay. Now we have another issue. There are no coefficients that are the same that we can cancel out. That means that we have to change one of the equations. So what we would have to do is we would have to change this one so that we either have a -2 to cancel out our x's or a -3y to cancel out our y's. So I'm going to choose the smaller number, okay, because smaller numbers are easier to work with. So what I'm going to do is I'm going to multiply this entire equation by a -2. So I'm going to distribute. Parker, I heard you say y a -2. Y a -2, I'm asking you that.
Because the last one was a -1, so why is this one?
Okay, well, let's go back to the last one. Why did we choose -1 for this last one over here? For example, 3.
That's usually what we normally choose, so I just went along with it. I didn't know we were going to do -2 on this one. That's fine.
Well, on this one, we had to change one of these to a -3. So all you do is multiply by -1. So on practice 5, I need to either turn my x to a -2 so I can cancel out my x's, or I need to turn my y to a -3 to cancel out my y's, and I chose the -2. So so either your x or your y coefficients have to be the same and opposite. So once I distribute my -2, I get -2x minus 2y equals 0. Now I can stack them and I can solve it. So I'm just going to move this here. So -2x minus 2y equals 0. So my x's cancel out. 3y minus 2y is a 1y, or just y, and 6 plus 0 is 6. So I just found my y. So with my y, I'm going to plug that into one of the original equations. Now, guys, I'm not going to choose this fraction equation. That would be silly. That's too much work. So I am going to choose this equation up here, x plus y equals 0, and I'm going to plug my y into this y right here. We're going to solve for x. So I subtract 6 on both sides, and x equals -6. Right, any questions on that? Okay, let's go to practice 6. Can somebody tell me what's wrong with this? What's the first step that we need to do? Yeah, you have to put this in standard form. This one's already in standard form, but we have to rearrange this. So we're going to, since this is a -3x, we're going to add 3x to both sides. And now we have 3x plus y equals 1. Now, do we have any coefficients that we can eliminate? Or can we eliminate our x term or our y term at this point? Okay, we have 1y and 1y, so that's one check. We can check that one off the list. And they're both positive. One of them must be negative. So what should we do to make one of them negative? Right? Yeah, so I'm going to multiply -1 times this equation. I could multiply it by this one if I wanted to. But I'm going to multiply it by this one because what happens when I multiply it by this one is my 5x and my 7x become positive. So now I have 5x minus y equals 7. Because when I distribute my -1 times -5 becomes a positive 5. -1 times a positive 1 becomes a -1. And -1 times a -7 becomes a positive 7. So now, can we eliminate a variable term? Yes, we can eliminate the y's. So now I'm going to stack it. So I'm going to move 3x plus y equals 1, stack it under the first equation, and now I can solve. And then once you find x, you can find y. Now, it doesn't matter which equation you plug it into, even the rearranged equations will work. Okay. I'm going to choose the second equation up at the very top to plug it into. So I'm going to plug 1 into the x. When you're finished, go ahead and check your answer. Okay, on practice 7, you must rearrange them into standard form and change one of the equations. So I'm going to give you time to work with your partner on that part, and then we'll check it before you move on, okay? So just rearrange and change and then stack them and see, and then we'll come back and check to make sure you're correct. So I'm going to pause the video while you work. Okay, so I rearranged the first equation by moving the negative 2y over, and I got negative 2x plus 2y equals 18. So that's the first thing you should have done. The next thing is that I rearranged my second equation, and this required 2 movements. I moved my 9 over, so I added 9 to both sides, and then I moved my 7y over, so that I got negative 2x minus 7y equals 9. Then, in order to eliminate one of my variables, I wanted to eliminate my x's. I multiplied my second equation by a negative 1 to make this negative 2 a positive. So are there any questions on those steps? Yes, Judy.
Why would you turn the second equation into like the negatives instead of the first one? Or does it matter?
It does not matter.
Okay.
No.
I did that with practice 6 and it was a different answer.
Well, you should have gotten the same answer. So if you did it with practice 6, you might have done some calculations incorrectly, but you should still get the same answer no matter which way you move it.
I moved the 2x and like didn't use the negative 1.
On the first one?
No, on the second.
So it should look like this right here, right?
Yeah, it still looked like that.
Yeah.
Okay.
Yeah, that's fine. So then at this point, you would stack it and you would start solving. So go ahead and finish up this problem, and then we'll come back and check our answer. Here's number 7. Any questions on that one? All right. Let's move on to example 8. Does anyone need to finish writing? Okay. All right. I'm going to pause just for a minute. Okay, so practice 8, go ahead and rearrange the second one into standard form. And once you do that, none of our coefficients are the same. But I want you to look at the negative 2 and the 7. Can we turn a 2 into a 7 easily? No, we would have to multiply it by a decimal or a fraction, and we are not going to do that. Can we turn a 5 into a 15? Easily, yes. And this one's already negative, and this one's positive. So all we have to do is multiply this negative 5 times a 3. But remember, if we multiply the negative 5 times a 3, we have to multiply the whole thing by a 3. So we're going to multiply every term on the inside by a 3. And when we do that, we now have the variable term of y as a positive 15 and a negative 15, and we can clear those. We can eliminate those. So I want you to go ahead and finish working on this, you and your partner, and then we will come back and check it. Okay. So I'm going to pause the video and come back with the answer. Okay, here is practice 8. Any questions? Okay, I'm going to have you do practice 9 from start to finish on your own. You will have really large numbers, but small solutions. Okay, so use your calculator to help you with the calculations to make sure you're doing it correctly. You should not have any fractions or decimals or anything like that. So if you do, go back and check your work. But remember, turn it into standard form, manipulated equations so that you have a positive and a negative variable term. Eliminate. Okay. So go ahead and I'm going to have you do this from start to finish on your own, and I'm going to pause the video. Okay, here is practice 9. So check your answer. Any questions? Okay, so for example 10, we need we need to either change both of our x's to a positive and a negative 12, or both of our y's to a positive and a negative 6. So I'm going to choose 6 because it's a smaller number. And I'm going to multiply this equation by 3 and this equation by a negative 2. And it doesn't matter. You could multiply this one by a negative 3 and this one by a positive 2. Okay. Now, once we do that, I have a positive 6y and a negative 6y that I can cancel out. So I'm going to go ahead and stack those. Okay. And at this point, you should be able to go ahead and finish solving. This one is not as challenging. After you get them stacked. Okay. So I want you to go ahead and finish solving, and then when we come back, I'll have the answer on the screen. Okay, can you just set it on my desk, please? Okay, so this is the answer to practice 10, 7, negative 10. Go ahead and take a look at that. Make sure you understand how to do it. So there will be some equations where you will have to change both of them so that you can eliminate one of the variable terms. And that concludes lesson 5.3, solving systems of equations using elimination.